Hello everyone, this is Mr. Appel, and today I'm going to do a little review of the end behavior of some basic polynomial functions. We're just going to explore some different polynomial functions and what different parts of those functions do to their graphs. So right now what we're just going to be looking at is the end behavior. And if you remember, the end behavior means where is this thing going when you go all the way out to the left and all the way out to the right. And so I want you to be thinking about that. I'm not going to really tell you anything. I'm just going to have you observe these graphs and how they change as I change different parts of the function. So if you can see over here on the left, and you'll get a chance to explore this in this graphing calculator, web-based graphing calculator called Desmos. If you haven't used it already, it's pretty cool. And what we're going to do is just explore what happens. So if you see here, I've got this function, ax to the nth power. So a is the leading coefficient, and n is the exponent. So right now, since a is 1 and n is 1, this equation is just 1x to the first power, which is just y equals x. And you see that the graph is what you would expect y equals x to look like, just a straight line going uphill. So watch what happens. What I'm first going to do is just change the n, and I want you to observe the end behavior. Again, what happens to this graph when I go all the way to the left and when I go all the way to the right, and start trying to make some observations. And as I'm doing this, you should be pausing and writing down your observations to be ready to talk about them later. Okay, so when n is 2, so again, the exponent is 2, so this is just y equals 1x squared. So you see this is just x squared, which is what you'd expect it to look like. So there's 1x cubed, x to the 4th, x to the 5th, x to the 6th, x to the 7th, and x to the 8th. So again, you should be paying attention to the end behavior. What happens is you go all the way to the left and all the way to the right with each of those. Now let's see what happens if I change the leading coefficient. I set the leading coefficient to positive 1. First of all, if I change it to positive 2, you should already know the answer to this question, but what's it going to do? How's that going to affect things? Well, I'll just run through these again quickly. So now that's 2x squared, 2x cubed, 2x to the 4th, 2x to the 5th, 2x to the 6th, 2x to the 7th, and 2x to the 8th. So hopefully you're thinking about what changing that to a 2 did. I'm going to go back, and I'm going to change this to a negative number. If it's 0, notice it's just a straight line, because now it's just y equals 0, not very interesting. But now I'm going to make it a negative 1. So now my equation is y equals negative x to the first. There's negative x to the second, to the third, to the 4th, to the 5th, to the 6th, to the 7th, and to the 8th. So again, I'd like you to just think about what you observed and write down any conjectures that you could make about how you could predict the end behavior for any function when you know the degree, in other words, the biggest exponent, the exponent, in this case n, and when you know the leading coefficient, whether that leading coefficient is positive or negative, how that's going to affect the end behavior of the graph.